All right, we're live. Hello, everybody. Welcome, welcome. Good morning or good evening, wherever you're coming in from.
Good to see everybody. We'll give people a couple of minutes here to filter in, or just a brief pause to filter in, and then we'll get started with the presentation.
Yeah, and while we're waiting for everybody to filter in, if you could let us know in chat where you're coming in from. We love seeing how global the audience is. Myself, I'm coming in from Las Vegas, Nevada, the city with all the casinos and stuff. Darian, what about you?
I'm in Denver, in Colorado. That's the city with all the mountains and stuff.
Is it still? Is there snow over there? What is it?
Yeah, I thought we were done with it, but we've got a cold front moving in today, actually, and we're going to get some snow this evening. So we're not quite out of winter's grip yet.
Okay, yeah. With that voice, I feel like you could be a weatherman.
Yeah, I've thought about starting a podcast before, but I just don't have many interesting things to say. That's the problem. Though that hasn't really stopped people from starting podcasts before, so I guess I shouldn't let my dreams be dreams there.
That's how they usually start. Ulbrich from London, welcome. Danny from Belgium, welcome as well.
Welcome.
Eric over on Twitch, hello.
Mexico, baby.
Mexico.
Nice.
Cool. All right, so we'll probably get started here in about a second. Bangalore from...
Hey, Bangalore.
Nice.
We definitely have, we definitely have a bunch of folks over in Bangalore that work with our team. They are fantastic. In fact, I see one of them in the chat right now. That's awesome. Good to see you folks.
Helsinki, Atlanta. Wow. Talk about global. This is fantastic.
Yeah. People from all over.
Right on. Well, thanks everybody for joining in chat. We're about to get started here. Let's see. Darian, do you want to take it away?
Yeah, why not? Thanks everybody for tuning in today. My name is Darian. Chris, would you mind sharing the slides?
Absolutely.
My name is Darian Wilkin. I'm a solutions engineer here at DigitalOcean. I've been here for about 6 years. So I'm a dinosaur in tech terms, but I've got with me Chris. Chris, you want to introduce yourself?
Yeah. Hey, everybody. I am Chris. I'm on the developer relations team, and I've been here for 2.5 years, which is also kind of getting up to dinosaur in tech terms.
You're right. Yeah. You're not no spring chicken anymore, Chris. But thanks so much, everybody, for tuning in. Today, we're going to be talking about migrating your database to DigitalOcean. Really, we're going to be talking about migrating your database in general. But obviously, Chris and I are with DigitalOcean. We have some cool tools that we want to talk about that enable you to more easily migrate a database from elsewhere to DigitalOcean. So we're going to talk a little bit about those tools, but also migration strategies in general and what you should be thinking about when you're looking to migrate your database. So, first thing I'd like to say is that it's actually easy to maintain state through migration, right? So that may be a shocking statement because state is the hardest thing to migrate generally. When we talk about state, we're talking about data written to disk. That can't just be thrown away. We have to keep all of that exactly as it was. Now, that part is actually pretty easy. The hard part of migration is keeping that state without the user noticing the migration. That's where the challenge, that's where the art comes into the science of migration. So that's one of the things we're going to talk about and focus on today.
This is a good one for me because anytime I've ever thought about migrating, I just said, whatever, the users can deal with some downtime. And I never went beyond that. So this is going to be good for me too.
Yeah, absolutely. I mean, I think we've all been there. And for certain levels of projects, personal projects, you obviously don't care about downtime. If it's your personal little cat blog, then it can be down for a couple of hours. Your users will survive. But when we're talking about a production application on which you run your business, that several hours downtime may mean the difference between retaining your customers and losing them. So this is a critical piece of the puzzle to think about. I'd also like to say, if anybody has questions as we're talking through this presentation, please don't hesitate to put them in chat. We'll try and address them as they come up. and make sure everybody has a chance to get their questions out.
And
So,
yeah, one more point to that. This will be recorded and will live on the DigitalOcean YouTube channel, so you can always come back and watch it later.
Absolutely. Who wouldn't want to hear me talk for even longer? That's what I say. No, but so what I wanted to talk about first when we talk about a migration is the different kind of archetypes of a migration. So this graph kind of talks about downtime, which is one of the big metrics for how successful a migration is. How long was the site down throughout the period of the migration? So on the left-hand side of this chart, we have data strategies. So these are strategies for moving your data from from your old database to your new database, right? Or your old service to your new service. And on the top, we have, instead of moving your data, this is how you move connections, right? So those Strangler and Cutover, those are ways you move connections between nodes when you're doing a migration rather than moving data. So we'll talk about what all of these methods are, but the clear energy here is moving towards that top left corner where we have seconds of potential downtime instead of minutes or hours. Now, obviously down at the bottom here, we have that stateless section. It's really not important for you to pay attention to. I just like to mention that stateless services are dead simple to migrate. So if you're ever considering a migration, identify which of your services are stateless first, and you can put those to the side and worry about them later. You don't need to really plan too much for those services. We're going to talk about what these look like in practice. So first, I want to address why we call that pattern above a strangler pattern. So what the heck is a strangler pattern? Well, Strangler Pattern is named after a strangler fig tree. And a strangler fig is a type of tree that does not stand up on its own. It grows on the outside of an existing tree. And on the left-hand picture here, you can see a strangler fig that is on a living tree. But eventually, the tree on which the strangler fig is growing dies, and the strangler fig has built itself up around the trunk enough that it can stand on its own. And that's the right-hand picture you see there. So you can see how in a migration where we are trying to slowly replace services without actually ever taking down the full application, that's what we call a strangler pattern. In the end, the strangler fig is standing up on its own, but the tree itself, there's always been a tree there, right? So that's the same way we approach a strangler migration, which we'll talk about in a minute, is that we replace the tree without ever actually taking it down.
That's so terrifying to me, that
right?
Just concept. And then I saw it, and it's even more terrifying than it sounds.
Yeah, it looks straight up evil, but even though nature is brutal sometimes, this ends up being a pretty effective analogy for the type of migration that we're gonna discuss. So first, I want to talk about a cutover migration. Now, this is a simple one, and this is probably what you think of when you think of migrating connections between services, right? So we have a very simple architecture here. This architecture has a user connecting to DNS, connecting to the application, connecting to the database. Now, if we want to change out our database, then obviously the first step we need to engage in is creating that new database and syncing the data with that database. Now, I say syncing the data. That doesn't necessarily mean logical replication. We'll talk about what the differences are between the different types of moving your data later, but this is just an idea of you're getting your data from one database to another. It could be a continuous migration with replication. It could be a point-in-time migration where you're taking a whole dump at one point and moving it over. We'll discuss what difference that may make later on. But once we've got the data synced, however we're doing it, the question is, how do we move connections from the app to the new database? And it's not that complicated. We change the connection info in the application. We say, hey, this was your old connection string. Here's your new connection string. And that seems like a dead simple way to do it. Of course, you'd want to do it that way. Why wouldn't you do it that way? Well, because in an application, in a migration of a complex application, you're not always dealing with a single app. Sometimes you're dealing with a dozen different applications that all need to talk to the database. In that case, if you try and time your cutover so that you are just switching out all of those connection strings in each of those applications all at once and doing this all kind of full speed ahead migration, you can have issues. It increases your risk factors in the migration. What if you miss a connection string? What if something is misconfigured? How do you troubleshoot that quickly? Do you have a rollback plan? These are all problems you can have with a more complex application that a cutover doesn't necessarily address. However, there is another type of migration, which is my preferred method of migration, which is called a Strangler migration. So we start with the same architecture, right? The user going to the DNS, going to the application, going to the database. But then we add in a proxy. So instead of having the app or the dozen apps connect directly to the database, all of those apps are going to be configured to connect to a proxy. This isn't a terribly complicated thing to do. You can connect them one at a time. You don't have to do it all at once because all you're doing is rerouting connections through the proxy as you're moving those connections to the proxy. Now, why do we do this? Because it makes the next steps a little simpler with a complex application. So now, of course, we're going to do the same thing we did before, where we start to synchronize our data with our old data with the new database. And again, the app doesn't care about this. We're not actually changing any connections yet. However, then once the data is synced, we're going to move the proxy's connection to the new database instead of all those individual applications. This means we have to change one configuration instead of a dozen, and it means we can do it immediately instead of over a period of minutes or even half an hour or more that it takes to change all those connection strings in various applications. And obviously, then we will remove the old database, and now we have the new database working. So again, I'd like to mention a cutover is just fine in terms of moving your connections over if you are working with a very simple application with only one or two connection strings. But once you get past that point, I strongly recommend a Strangler pattern migration as it simplifies, reduces risk, and makes it easier later if you'd like to perform an additional migration. I wanted to address something in the chat. Somebody said several hours because earlier on one of the slides I indicated that it can, with a point in time migration, take several hours to complete the migration. They're like, hey, why is that? That's because with a point in time migration, which we'll talk about in a minute, you have to take an entire dump of the database, and while that dump is running and transferring to the new database and the new connections are being set up, you can't have write time. You can't be writing to the database while that's going on, or you'll lose that data in that interim. If you've got a small database, you're right. It can take only a few minutes for you to perform a dump, transfer it over, and start up the new database. However, if you're working with multiple terabytes or even hundreds of gigabytes, it can take quite a bit of time to perform that transfer. So let's talk about. I just wanted to address that question real quick. So thanks for that. So let's talk about the differences or the procedures for a Strangler versus a cutover migration. So a Strangler, as we saw, the first thing we're going to do is create a proxy in front of our existing service. We want to send all connections to that proxy instead of directly to the database. Okay. Next, we're going to connect the database to the proxy, or to connect the app to the database, or app to the proxy and proxy to the database, just like we did in the diagram. And then we're going to move the data from the old to the new service. Now, again, we'll talk about how we're moving the data back and forth in a minute, but it's important to understand that this is just the phase where that happens. Finally, once the data is synchronized, we are going to point the proxy to the new service, and then we're going to destroy the old service. It's fairly simple. The cutover pattern is, and then obviously optionally with a Strangler, we can remove the proxy. Proxies sometimes give benefits. We can keep it around if we ever want to perform another migration. It's much simpler. But when we go over to cutover, the first thing we're going to have to do is stop all writes to the existing service. And that's one of the problems here, and one of the reasons a cutover is less desirable than a Strangler pattern migration. Because as soon as we are moving the data over, we cannot have the existing app writing to the database. So once we move the data over, then we adjust the connection, the DNS or connection parameters. You can do either. I recommend connection parameters, as DNS can take some time to propagate if you don't prepare. Then once those changes propagate, you're going to resume writes on the new service. And then finally, you can destroy the old service. So the problem with the cutover migration is from that first step where we have to stop all writes to the existing service to that step where we resume writes, that's all downtime, right? So it could be a few minutes, but it could be a lot longer depending on how we're moving our data around. Okay, now let's talk about probably the most time impacting or downtime impacting part of this migration process, which is how you're moving your data between the two databases. This is something that is probably the most complex part, because obviously, like I said earlier, if we're performing a migration, the hard thing to do is to keep the user from noticing that downtime, right? Or having any downtime at all. So what are the differences between these two types of migration? Well, continuous migration is based on logical replication. So when we talk about a continuous migration, we're saying we are replicating every transaction on our original database to this new database, right? So every transaction, it gets copied over as it's going, right? Obviously, that means that the databases are constantly in sync, but more importantly, it means we can continue to write to the losing database up until that point where we're switching connections, right? Because it always is going to copy those changes over. The continuous migration is best for read-heavy workloads, okay? So if you have a database that reads a lot of data but doesn't necessarily write a ton of data, a continuous migration is better for you because replication works very well with read-heavy workloads. It doesn't work as well with write-heavy workloads, which we'll talk about in a second. With a continuous migration, there is little or no downtime. And that is obviously the key that why we think continuous migrations are far superior to point-in-time migrations, is that they really reduce the downtime we have to deal with. However, they do require super user permissions on the losing DB. You cannot easily set up logical replication on a database unless you have super user permissions on that database. So that is a limitation of a continuous migration. That may be why you choose a point-in-time migration. You may not have super user access on your losing database. And finally, a continuous migration is frankly complex to implement on your own. It requires you understand how to implement replication and troubleshoot replication if there's replication lag. There are a lot of aspects to this that can be complicated to figure out if you're not experienced. So let's contrast this with point-in-time migrations. So while it's continuous is based on logical replication, with point in time, we're taking a dump of the DB at a given point in time, right? We're saying, hey, stop all writes, give me all the data in the database at this moment. Now, like we said, if it's a very small database, that can take very little time. But if it's a large database, you have to wait for all that data to download, and then you have to wait for all that data to transfer to the new database. Point-in-time migrations are better for write-heavy workloads. If 80% or even 60% of your database traffic is writes, a continuous migration may introduce replication lag that causes you to delay causes you to increase your amount of downtime while the second database catches up. So point-in-time migrations are better for write-heavy workloads than continuous migrations because there's less risk of replication lag, or there's no risk of replication lag with point-in-time, obviously. Point-in-time migrations, they are going to have downtime. Now, depending on the application, if your application isn't sensitive to read-only databases, if it can still operate with a read-only database, then you'll have less downtime than with a database that relies on writes, right? So, for example, I believe WordPress really needs to be able to write to the database at all times. So, if you take down writes for the database, WordPress mostly won't function. So that's an example of one that really relies on writing to the database. But if you have a read-heavy application, which is ironic because you'd go with write-heavy for point in time, that's where we'd see more downtime. Or less downtime, I apologize. And then the reason you might select point in time, or two reasons, is one, it only requires read credentials. You don't even need write credentials on the losing DB in order to perform a point in time migration. Obviously, you would have write credentials, but that's beside the point. It doesn't require many permissions at all. You just need to be able to see all the data. It is, as a result of that, the simplest way of migrating a database. You enter a command, you get the file, you enter another command to input the file into your new database. Dead simple.
One thing I've found too with point in time is when I'm doing like the actual dump, I feel like the site slows down sometimes. So for users that are just like on the site, it just doesn't, it crawls.
Yeah, absolutely. Because the database is using all of its available resources to produce that SQL file for you.
Yeah.
100%. Whereas replication is less computationally intensive over the long term or over the short term than those point in time or backups, dumps. That's absolutely correct.
Cool.
So the big question comes up. All right, so should I be managing my own database? Should I be administering my own database? Should I be a DB admin? And in my expert opinion, probably not. I know this may strike a lot of developers in kind of a bad way, where you say, hey, look, I can do this. And you can. You're absolutely right. You can run your own database. You have that capability. You can pour Tabasco in your own eye. That's your choice. You're free to make that decision. But I've seen a lot of cases where startups start and they say, hey, we're going to build everything ourselves. It'll save us money. We'll know how everything works. At some point, that home-cooked database administration that you've got going is going to have a problem, and you may be able to get through it. You may not, but you are going to continuously pour hours into developing and maintaining your own database infrastructure. And in my experience, it is almost always easier and better in the long term, and saves you time and money in the long term, to make use of a managed database offering. This is a solved problem. Databases are, not that they don't ever go down, but databases can be administered automatically through tools that exist out there, and it's not necessary for you to bang your head against the wall. Yeah, exactly. The whole Michael Scott no meme. It's 100%. We get that reaction sometimes. People are like, look, I can do this. You're right, you can. You absolutely can. You just shouldn't. So let's talk about why it's a little easier, or a lot easier, to make use of a managed database. And that's really the features that come with it. These are all features on the right-hand side that you would need to implement yourself if you wanted them on your own personal database. These are not easy things to implement on your own. It's much easier to use a managed database. These features are things like an online migration tool, right? So this is something we're going to talk about in just a minute. That continuous migration strategy we mentioned earlier, DigitalOcean just released a tool that will allow you to migrate, and we'll talk about that in just a minute, exactly how that works. Forget about administering your own DB. Focus on the business functions or other efforts. Self-maintaining DBs of the future. I completely agree. I'm going to say Bulant. I hope that's a correct pronunciation of your name. Thank you for that comment. I totally agree, and that just speaks to what I said a minute ago. Online migration, it's hard to enable logical replication on your own, or at least it can be, depending on the database and the activity. So having this be a built-in feature of databases makes it so easy to get started. Automatic failover. This is the big one for a managed database, right? Automatic failover is critical for any database that wants to promise uptime for its users. So I apologize, my smart home is talking in the background here. Automatic updates. These are also something that normally is a pretty scary proposition. It's scary to perform updates on your database because you're like, what if this goes wrong? Automated updates and automated configurations for rolling back if the update fails solve this problem for you. Global read-only nodes are another one that's just annoying to implement on your own. This is where you can have read nodes for your database in geographically distributed locations. Makes it so much faster for people in those locations to access data, and reduces the read workload on your primary master database. And then finally, point-in-time backups. We have a 7-day window point-in-time recovery, meaning you can rewind your database to any point in the past 7 days, any 1 second interval in the past 7 days, And you can either restore your database to that point, or you can fork a copy from that point that you can use to recover data from that point without hosing your existing database. These are all features that are incredibly complicated to implement on your own, and together this would be a nightmare for an individual database administrator to implement and maintain. That is the clearest reason I can give for why managed databases absolutely make sense.
Yeah, and everything on this list, if I even think about implementing myself, just brings on anxiety and fear in my brain. And I don't know, that ease of mind is definitely top of my list for reasons.
And that's a great point, because it's overlooked sometimes. It's like, hey, we can do it, but how much stress is this going to cause my team? Even if you succeed and there are no problems, how much agita did it create in your team to get to that point? Is it worth it? Maybe it is for you. Maybe it is. I'm not going to say it's not. I just know I've worked with quite a few customers for whom it was not worth it over the long run. And they ended up going with a managed database offering anyway. And as soon as they did, they were angry that they hadn't done so earlier. So let's talk about DigitalOcean's managed database offering a little bit. Forgive me for the advertising, but I do think it's a great offering. We offer 4 database engines for managed databases right now. Most of those features are available on all of these engines. Redis is a little different, but that's just because it's a bit of a different type of database. We offer MySQL, Postgres, Redis, and MongoDB at this time. And like I said, most of those features are available for these. The one exception, or one of the few exceptions, is we do not yet have online migration for MongoDB. That's coming this year, we hope, very soon, but I can't give you an exact timeline on that. However, MySQL, Postgres, and Redis, all of those databases feature a functional online migration tool at this time. It's really neat. So this is what it looks like. This is all. This is all that is needed for you to perform a database migration on DO. You just need your database credentials and the URL. That's essentially it. As long as you have super user permissions with those credentials on that database, on that losing database, we will take care of the sync for you. You can start the migration. It'll keep it synced until you're ready to perform the switch, and then you can say, all right, this is the primary database now. It makes that continuous migration strategy that we talked about earlier, where you can have seconds or minutes of downtime instead of hours, makes that process so dead simple. I think that this is one of the more beautiful tools that we've created, and just how simple it is to use for such a complex goal that it accomplishes.
Yeah, and I'll agree with that. I got into our internal beta, and they were like, go test it out. I went to go looking, and I'm like, where's the rest of it? It's like, that's it. But it's good. It works.
Yeah, exactly. Like, you get to this and you're like, okay, online migration tool. I'm gonna need to put in a lot of details here. I'm gonna need to set up the schema. I'm gonna need to do all this. No, not at all. You find out your credentials and you're done. It is so easy. Yeah. Thanks for that. Just posted the migration page, talks about the migration tool and how it works. Doesn't just work for Redis, works for MySQL and Postgres as well, which are obviously very popular databases. So strongly recommend people go ahead and try it out. You don't have to actually move your DNS over and move your application over to test out this migration tool. If you've got a running MySQL, Postgres, or Redis database somewhere, give it a shot. It'll grab the replication. It'll copy over all the data. You'll see just how easy it is to move that database over to DigitalOcean. So that's really the bulk of what I wanted to talk about today. Yeah, and that's a great question. That's correct. We offer MySQL 8 right now. We do not currently have MariaDB. One of those things where they're not entirely binary compatible. However, they should be generally compatible between SQL files. If you're moving an SQL file from MySQL to MariaDB, there shouldn't generally be issues. Maybe an encoding problem, but really they should be generally fully compatible. So no issues moving MariaDB to MySQL in general. MySQL to Postgres, of course, is a different question. That is something you need to convert. So with that, I guess we can open the floor to any questions folks have. I know you folks have been kind enough to post those questions throughout this discussion. As well, I've put Chris and my emails at DigitalOcean here. If you guys have any questions later on or would like to talk about this, you can send us an email. But we got a question here. Does ManageDB and DO support DB replication with read-only nodes? So if you have credentials, super user credentials on a node, you can migrate that database to DigitalOcean. However, with a read-only node, oftentimes you do not have super user permissions. So I don't know that you'd be able to do that. It depends on the setup you've got going. But theoretically, as long as you have super user permissions and can set up logical replication, it's not a big deal. I would say I would go from the primary instead of the read-only, just because a read-only is also a replica in most cases of a primary database. And if you go 2 layers deep in replication, a lot of times you can have continuous replication lag that stacks up on itself and gets worse and worse and worse. So I generally don't recommend a daisy-chained replication strategy. I hope that daisy chain isn't too colloquial of a term, but just plugging in multiple replications back to back is a recipe for replication lag, which can delay your migration significantly. Yeah, another good article just posted by my team here, the docs migration strategy, or the migration strategies documentation. We talk about kind of what logical replication is in that article. It's a great article if you're curious kind of what the fundamentals of this art and science are. But great. Any other questions from anybody in the chat?
I'm just thinking for myself how useful this would have been, because I still have a database that is like, I want to say 4 or 5 years old on an old droplet that I still don't want to destroy the droplet, but I've never gone in, I've never updated it, I've never done anything to it. I should go try out this tool and then just finally get it off that droplet and have it somewhere where I don't think it'll break.
Exactly, right? Somewhere where the data is guaranteed to be recoverable if there's an issue. Yeah, 100%. The ability to rewind, a corruption issue or something like that, or bad data being put into the database. The fact that you can rewind that easily is so great. Yeah, so we did talk about potentially showing a demo here. So somebody just asked, could you show us a demo of some kind, never seen a continuous database backup? So that's the interesting part. We were going to do a demo, but the tool itself is so easy that this is essentially the demo. You really just literally put this. Yeah, okay, so that's a great question. So we can talk about that. So the question is, what happens when a user changes his data during a proxy database change? So when we talk about a proxy database change, I think you're talking about a Strangler Pattern migration, which is how we move connections and not how we move data. So when we talk about the migration here, so let's go back a few slides. Oh gosh, so many animations I have to get through. I apologize. So I wanted to talk about this slide here. So I think Spiros is referring to a continuous or a Strangler migration, but potentially either continuous or point in time. So if you're doing a continuous migration, that's what's great about a continuous migration, is you can continue to change the data on the losing database throughout the entire migration. Up until you're actually switching those connections over, you can continue to write to that primary database. That's one of the great aspects of a continuous migration. Alternatively, with a point-in-time migration, where you're taking a single dump of the database in one point in time and trying to move that over to a new database, once you initiate that dump, once you start that MySQL dump or Postgres dump of the database, right? Yes. Once you start that dump, if you alter the data on the losing database in any way, you can lose that data on the new database. You may not get that data. And of course, once the dump is complete, any writes to that database will not be transferred over because, of course, you have stopped copying data over. So that's the risk of a point in time, is that really as soon as you're starting that point in time migration, you must stop writing to the losing database. Otherwise, you're going to lose data. And yeah, good point, Eric. We all love to use animations on our slides until we have to go back a few slides. 100%. That's a little bit of a little bit of negative on my part with this. Wish I could click back 20 slides with a button, but oh well. Yeah, absolutely. So any more questions in the chat? Happy to answer your question, Mohammed. Yeah, I don't know if I'm getting the full question, Mohammed. So if you could, if you enter it all in one comment, I might be able to see it. But anyone else who has questions, feel free to enter them. This is a complex process, and yes. So let's talk about Spiros' question. He says, at every point in time, the two databases are synchronized until I change to the new database. That's correct. So if you're using a continuous migration, then what happens is every time a query writes to your losing database, every time, the replication on that database will say, okay, also write this to the new database, right? So it just copies every single query that gets written in, right? So when you copy every single query that gets written in, that means that after a second or two, depending on the latency between the two databases, after that time, they are exactly in sync again. So yes, there is a few seconds of when you're actually changing over the connections where you need to stop writes on the primary database or just enable writes on the new database. There may be a few seconds there where you have no writes or where loads don't quite work as you expect on your home page. But then after that, you can write to the new database and it will have everything that the old database had on it. That's exactly correct, Spiros.
So what's a good strategy for knowing when to switch your app over to the new database?
Yeah, so this is something, there's a couple things to think about with this. When you're thinking about how to switch your app to the new database, or when to switch your app to when to actually perform that cutover, it depends on the way you're doing things. So we talked about the fact that a continuous migration or logical replication strategy, it can cause replication lag if you have a write-heavy database. If there are a lot of those writes going on the database, there can be a delay that builds up over time between when something is written to the main database or to the old database and when it gets replicated to the new database. In this case, if you notice that you've got replication lag, you need to give your database non-writing time to recover that replication lag and get caught up on the new database. So that's one thing to consider with a continuous migration. If you start to see replication lag, you're going to need to have a period of no writes to the old database while it catches up before you can switch connections over and start writing to the new database. Okay. With a point in time migration, the decision really comes around when do you want your users to be offline, because they're going to have to be offline. So a lot of times with point in time migrations, you'll do it at 2 a.m. in the morning for your primary user base. You'll do it really late at night when there's very low traffic, and as a result, you can disrupt minimally the users that you're working with. But generally, with a continuous migration, if you're not experiencing replication delay, you can do it whenever you want because there's going to be almost no noticeable downtime. So Spiros asked if my new database has its schema altered, how it knows where to put what. So in this case, the schema will be the same on the losing database and the new database. That's that's a fundamental aspect of this, is that you're moving like database to like database. So the replication will copy the schema that you're using. It'll move everything over as it is on your old database. Victor asked, is the proxy in a Strangler pattern the best advantage, but also the best inconvenient? What if the proxy crashes? Yeah, absolutely. So Victor's talking about the idea of, do we want to add in another layer of complexity here, right? We had this, sort of two-tier system or three-tier system. Do we need to add a new tier? Doesn't increasing the number of parts increase the likelihood of an issue? And yeah, potentially, Victor, it does. That's actually exactly why a Strangler pattern is good when we're dealing with a complex application rather than a simple one. Because with a complex application, when we are going through a migration, we're talking about changing the connection strings or DNS for multiple different services. That is introduced complexity. If we can simplify those and say we actually only need to change it in one place, just like with global variables for developers out there, for people who code, if you only have to change it in one place, there's lower risk of you missing something and having an issue that you can't fix in a short amount of time. So you're 100% correct, Victor, that if you do not need the extra complexity of a Strangler migration, you shouldn't introduce it. You can go with a cutover. It's fine. You can do a continuous cutover and have very little downtime or almost none at all. I hope that answers your question, Victor. As far as what if the proxy crashes, you can use a load balancer for this in many cases if you'd like to. And a lot of load balancers have the capability of, for example, DigitalOcean's managed load balancers can be are self-healing. So if it does go down, it'll recover on its own. You can also build a redundant proxy system, but yeah, absolutely. I would say you don't necessarily need the proxy unless you're dealing with 4 or 5 different places you're going to need to change connection strings. But good question. Yeah, it's one of those situations where, in some cases you have to briefly increase complexity to reduce complexity in the long run, right? I always like to think of, DigitalOcean is very simple. We have a very simple interface, very, very easy to use. Simplicity is one of our watchwords. But that's why, sorry, I lost my train of thought there. But simplicity is one of our watchwords, which is why it's a lot of people think like, oh, our backend must be simple. Not necessarily the case. It's actually quite complex to make a simple end, right? Like to make that simple front end, we have to have some complexity in the back end that hides the complexity from the customer. So a lot of times simplicity in the end result comes from complexity in the process. Spiros, continuing my previous statement, what is the point of this migration if no schema can change? I mean, only for resources. Yeah, so there could be a lot of reasons you're performing a migration, right? You could be migrating because you want to use a managed database instead of an unmanaged database. That's probably the most common reason I see users performing a migration within DigitalOcean. But additionally, you may be moving between clouds, right? You may want to get off whatever cloud you're on right now. Maybe they're too expensive, maybe they're too complicated. And you want to move to a different offering. Maybe you're performing a whole cloud migration of your application. You're moving from one cloud to another. That happens more than you might expect. So there are a lot of reasons why you might be moving your database other than changing the schema. But good questions. Any other questions in the chat?
Perfect. Yeah, this was fantastic. Thanks, Darian.
Of course. Yeah, this has been a pleasure. It's been awesome talking to everybody today. Like I said, and I'm not going to go through the 500 clicks it'll take me to get to the last slide again, but like I said, my email is dwilkin@digitalocean.com. If anybody has a question, feel free to email me. Always happy to chat with you folks and clarify anything. I'm certainly not infallible. So if you saw any mistakes here today or something you think I could correct next time, I'd love to hear it. I always enjoy engaging in those conversations.
Right on. And if everybody is all good, no more questions, and you know where to find Darian, if you have any more questions, thank you so much for joining. This was a lot of fun. I learned a lot. I have a lot of things to go do now. But it seems like the migration tool is pretty easy. So I can just go ahead and go do that.
Yeah, absolutely. It's been great.
One last
Thanks for having
question.
me.
Sorry.
Oh, yeah. Can migration happen from one DB to another which has a higher version in case we need to upgrade the DB? Okay. I would upgrade first, or I would upgrade before or after the migration. I don't know that. I would imagine there would be a massive number of problems migrating data. There could be a massive number of problems migrating data from an older version to a new version. I would perform the upgrade separately from the migration. You just want to reduce the amount of complexity in the migration. You can try it. I'm not saying it won't work. You might have some issues with the schema or something like that.
Cool. Right on. Well, I think that wraps it up for everybody. And right on. Thanks again, Darian. Thanks again, everyone, for joining and hanging out with us. I hope you learned a lot today, and we will see you in the next one.
Thanks, everybody. Have a good one.